My name is Sijie. I'm trying to share the latest integration we have done with Flink 1.9. And before that, just a bit introduction again. I'm a PMC member of Apache Pulsar and also the PMC chair of Apache Bookkeeper. Bookkeeper is a sub-project, I would not say. It used to be a sub-project of Zookeeper. It was kind of coming out of Zookeeper. And the aim of Bookkeeper is kind of building a scale-out log storage, and Pulsar is using Bookkeeper as its mastery storage. I used to work for Twitter and Yahoo before, and I'm interested in any event streaming technology. Before that, just do a quick survey, how many people heard about Pulsar before? Okay. So we usually use one sentence to describe Pulsar, which is flexible pub submasking, backed by a durable log storage. So from the first part of the sentence, you know it's a pub submasking. So you may already know a lot of pub submasking system like Kafka, or maybe the traditional mastering queuing system. But the difference is kind of stated by the second part of the statement is it's backed by a log storage. I'm not going to a lot of details about the Pulsar because we have a boost there. If you want interesting into more details, then welcome to stop by. We can talk more about the internals of Pulsar. But a few highlights of the system is first, it's a multi-tenant system. Which that means saying is all the topics is not stored in a flat namespace. It's more in a hierarchical namespace. You have tenant, namespace, and topics. And it provides a certain isolation between the tenants and also access control. And it's all policy-based control. You can specify a policy for your namespace, how much storage space you want, and what is the bandwidth you allocate for a tenant. The second highlight is a unified mastering model. With that being said, is you just store one copy of data, but you provide a different way to consume the data via different subscription type. A simple way to think about that, it's a combination of the traditional mastering queuing, RabbitMQ style worker queue, and Kafka style streaming. And the third highlight is, from architecture-wise, is a segment-centric design, and it also have tier storage, so you can offload the segments into a tier storage like S3 or HDFS, and you can really think Pulsar as an infinity segment stream storage. The fourth thing is it provides a built-in schema management. With schema information that you can think about the stream is not a raw byte streams anymore. It's a structured event streams. And Pulsar would managing all the schema information and also the schema evolvement. And the main talk today, I will be sharing how we integrate Pulsar with Flink with schema built-in the mind. And the last one is more from architecture-wise, is multi-layer architecture. It simplifies a lot of operations, and it also provides a rebalance-free architecture. With that being said, is you don't need, when you adding more storage node or brokers, you don't need to rebalance the data to copy the partitions from old machines to new machines. So this is kind of a highlight. For more details, welcome to talk to us if you're interested in more details. A brief history about Pulsar is the idea was kind of coming out of Yahoo around 2012. The aim is to try to build internal messaging cloud. And it has been running on production for 5 years and serving many of the applications. Yahoo open source around end of year of 2016 and donate to foundation around June 2017. We run the incubation in Apache Foundation for about a year. It graduated as a top level project. And right now we have about 25 committers from about 9 companies and 4,200 stars and 1,000 forks. And the adopters is spanning from different regions, like Yahoo Japan. In Asia, we also have Tencent adopting for its core bidding service. And in Europe, we have OVH Cloud, the Hack Group. I think there are many different adopters. For the full list of the Power BI, feel free to access the link here. We see people think about Pulsar initially as a Pulsar messaging system. And then the use case that we have been seeing is in Pulsar is mainly the main driver is the using in some core online business like billing, payments, or trading service, because people go for Pulsar for its stronger durability and stronger consistency. But because it's the unified messaging model, it can be used in a lot of traditional messaging use cases like worker queue, push notification, task queue. And we see a bunch of the adoptions is they use Pulsar to unify their different messaging architectures, like the combination of RabbitMQ and Kafka into one unified messaging backbone. And also some of the IoT use case. And the last one is we see that people start exploring using Pulsar in Flink to build a unified data processing stack. And that's also one of the parts that I will mention as part of my talk. And just extend a bit about the Pulsar use case. Then one of the use cases that we recent adopted is from Tencent. Tencent is using in its core bidding service, which is serving about 30 billions of export money in the whole Pulsar in the whole Tencent group, and it's serving 10 billions of transactions every day. And the main usage of Pulsar is kind of for both online service and also the offline real-time analytics. For the online part is using all the money purchase or billing payments were just going to Pulsar because of the strong consistency and also durability. And offline it would use Flink to do the real-time processing to process the data in the transaction messaging queue and to reconsolidate all the payments. So I think it's a very strong use case. It's combining both online use case and also real-time use case into one system, and that's kind of the power of Pulsar. Okay, sorry. And sorry about to talk about a bit more about Pulsar, but the main talk is about one of the core use cases that we kind of exploring with Pulsar and Flink is to achieve unified data processing stack with Flink. And to start the integration between Pulsar and Flink is based on one principle that we how Pulsar view the data. The data in Pulsar is abstracted as an infinity segmented streams. With that being said, it provides two levels of reading API. One is PubSub, the other is segment. I'll mention that a bit later. So just give you a very simple concept. It's very similar as any other PubSub messaging. You have the entity called topic, which is the entity for storing all the messages. For the application interact with the data, you have the traditional popular PubSub messaging model. You have producer producing the message to the topic. You have consumer consuming the message from the topic. And logically, it's also divided into topic partitions. So you can have multiple partitions. And to call it out here is the partition is a logical concept. It's a logical entity. With that being said, is a partition is not tied with any storage node, and it's just a logical concept. Physically, a partition is kind of divided into multiple segments, and the segment is represent a sealed append-only log, and then the segment can be stored in, for example, Bookkeeper or S3 as a blob. So this is kind of the how the data has been presented in Pulsar. And what we think the fundamental principle of the Pulsar is, if you're looking into that, is the partition is kind of a scale-out unit. But a partition itself is abstracted as an infinity append-only streams. And because it's segmented, and when you keep appending data into the partition or the streams, you would have you would generate a new segment, and the old segment became aging out. So we introduced the concept of tier storage. So with that being said, is for your latest data, it can be cached on your latest broker. For the warm data, it can be kept in the bookkeeper. And for the old data, it will be automatically tiering into a tier storage like S3, GCS, or like Azure Blob Store. And the good thing of this abstraction is for your application, it's a unified view of your data, so it's infinity streams. But you don't need to care about like where the data is stored. It's in broker, it's in bookie, or in a tier storage. So you just have one view of your data. And the benefit, a lot of benefits bring by this unified view is you just need to have one catalog or one metadata system for managing all your data. You don't need to really have like a MQ for your latest data and you write a connector to dump the data from MQ to your HDFS. So that is kind of the fundamental principle that Pulsar present as infinity streams. And as I mentioned before, is Pulsar presents stream as a unified view on data, but it also provides two levels of reading API. One is the streaming way for consuming data, which is PubSub. And because the data is segmented into multiple segments, so you can use the segment reader to read directly from the storage, like either from bookkeeper or directly from S3. You don't need to go by another broker. So the two-level API have their own benefits. Like for PubSub, you read the data directly from broker, so it's all about latency. So you can get the data as soon as the data arrive in a system. And you can have the different subscription mode to consume the data, like failover, share, key share, and also you can reprocessing all the data by seeking your subscription or seeking your reader back to a given time or given position. And the segment API provide a much fine-grained parallelism for you to accessing your data within a streams. It's more close to like a batch processing model in HDFS. In HDFS, you have file, and file is truncated into multiple chunks. So that segment provides a way for you to batch process all the historical data. And we do support a few predicate push down, like publish timestamp. And we are also working on event time-based predicate push down. So that would kind of helping a lot on the batch processing. And with the principle of stream as a unified view on the data, all the data processing on Pulsar can be treated as you process the data with boundaries or without boundaries. So it's a bound stream. Bound streams can be broken down into a set of segments. You can process the segments in parallel. But if you are running a streaming query, continuous query, so it's more using a streaming model to keep tailing the data from streams. So that is kind of the eventual the vision of how Pulsar present data for any computing engines. So any computing engines can just leverage the both PubSub messaging API and also the segment API for access the data in a more efficient way. So that is kind of the foundation we have in Pulsar, and we did a lot of integration with Flink. We did an initial integration like about maybe 6 months ago with Flink 1.6. But at that point, the integration is done very basic. It's more about like, it doesn't really using Pulsar as a storage system. It's more using Pulsar as a pipe. Like we integrate Pulsar with as a source connector, as a sink connector. It doesn't like there's no like unique advantage that Pulsar provide in this integration. Is like any other messaging queuing system can also do the similar thing. We did have a blog post in Flink, and thanks for the Vivorica team for like helping with the blog post. And so give you a quick idea about like how the previous integration we did is, so you can specify Pulsar source, and it will specify like how you connect to the Pulsar connector, Pulsar cluster, and you specify the topic, and then you can connect the streams with any Flink processing logic, and at the end you can also produce the result back to Pulsar. So I mean, at this integration, it's all about the just like connector, source connector or sink connector. There's nothing special there. But that's not cool. I mean, it doesn't leverage the whole power of Pulsar. And especially if you take a look at the program here is in the source, in the application, you have to manually specify what is the schema of your topic or of your stream. And with that being said, is in an organization, your schema of your topic is not static. That means, your producer team might be keep changing, or your business team might be keep changing, adding fields to your schema. So the integration we did before doesn't really fit into the power that Pulsar provide, because all the schema information stored in Pulsar is not really like fully being used here. So then we kind of like rethink what would be the right integration should be done between Pulsar and Flink. And think to the new 1.9 release, and Alibaba contribute back a lot of like enhancement, like a type system, table API, and also a lot of good things from Blink. So we rethink our integration from scratch, and we basically think the first thing on the integration is we need to bring schema into the picture, and schema should be the most important thing when we do the integration. And we need to make a table API as the first-class citizen. And with table API being the first-class citizen, then you can leverage a lot of tools in Flink, like you can run SQL queries on top like Flink. And the last thing is, I think in 1.9 there's a catalog API introduced in Flink. So with the schema integration, we want to make Pulsar as a catalog of Flink. So you don't really need to like specify the environment information in your program. You can just register Pulsar as a Flink catalog. Then you can just run like Flink queries on top Pulsar. So that's our kind of integration. Before I deep dive into the details, let me just show you a quick demo. Like just show how to like register Pulsar as a Flink catalog. So let me just start a look. Is it okay that you can see all the content? Okay, I guess so. And let me just start a Flink cluster locally, and I have I download the Pulsar like distribution, and Pulsar provide a standalone mode, so you can just run everything locally. So just start, sorry, I guess, sorry. And then you can just register, you can just add, I think in the 1 line there's a Flink circle client. Then you can specify the catalog in the circle client. And so that is one way you can define the Pulsar catalog, is you register Pulsar catalog and the type is Pulsar. And you can specify a default database. And the way how we did it is we map Pulsar's namespace to a database. So all the topics within the namespace will become tables of a database. And you can specify the location, how the circle client can connect to the Pulsar cluster. And once you have that, you also need a connector that is a Pulsar Flink connector that we built for integrating Pulsar with Flink. So once you have that, you can specify the jar in your circle client. And when it started, and then you can just show catalogs. And then we see there's a Pulsar catalog coming up. And then you can use catalog, Pulsar catalog. And then once you use the Pulsar catalog, you can show the databases in the Pulsar catalog. So as you can see here, it listed three databases. It's the three namespace in Pulsar cluster. It's like public tenant, default namespace, public tenant, function namespace. And once you know which database you want to use, you can just use the database. And then you can show tables. So this is the topic. Topics will be mapped directly to the Flink Flink table. So once you have that, you can run a circle query on top of it. Let's just keep this thing simple. Is this So I think it's a streaming query that is keep watching any data arriving in this topic. And I have a separate example that is publish Avro structure to the topic. So I publish 10 records into the topic, so you're automatically showing up as the record. As you can see here is there's some multiple fields. One is the ID amount, which is coming from the Avro struct. And some of the meta fields that are prefixed with 2 underscore, that are kind of the metadata information coming from the Pulsar messages, like the key, which topic, and what is the master ID, publish time. I think we have event time, but because the screen didn't show, it doesn't show up. So this just give a quick understanding how we integrate Pulsar with Flink. With that being said, we want to make people who use Flink, we want to provide the Pulsar users who use Flink for processing data the seamless experience for querying processing data within Pulsar. You don't really need to register additional information. So as you can see here, you can also describe, let me describe the table. Oh, I don't remember the syntax. Yeah, so as you can see here is you're listing out all the fields about this topic. So this is a very short demo about like how it looks like about the latest integration that we did, bring schema as the first-class citizen. And so that's going into a bit details about how we did that is, so before that I would like to introduce a bit about the Pulsar schema. So Pulsar like put the schema as the first-class citizen into the whole system design. It's not like external system. You don't need to set up an external schema registry. It's all built into the broker. And it's the consensus of the data at the broker side. And the data schema is associated with each topic, so it's a per topic basis. And all your producer and consumers are sent data with the schema information. And when broker receives the messages, it will do all the validation, it will all managing all the multiple versions of the schemas, and we handle all the schema evolution and compatibility check. And just give you a quick example about how Pulsar schema looks like. This is two examples. One is producer, the other is consumer. Producer can specify like which like schema you want to use. And then when you send the data, you just send the POJO class. You don't need to specify you don't need to serialize the POJO back to bytes and send with bytes. Similarly, consumer can also specify a schema to receive the data. And then on receive the data, Pulsar would just automatically validate all the schema information, fetch the schema of the given version, and then deserialize the data back to a POJO struct. And the core of the schema is Pulsar store the schema information as part of the metadata, topic metadata. And this is how the schema information looks like. There's a field called type. It specifies what is the schema type, JSON, Avro, ProBuff, or Swift, or any other struct. And the schema field is a JSON definition, like including all the fields that in this struct. Like in this example, there are 3 fields. Is field 1, I think it's a typo, file 1, file 2, and file 3. And this is kind of the core of the schema information. And the schema is also, I just show you a quick workflow about how the schema works. Is application will specify a schema that in a producer or consumer, and the producer connect to a broker. It will send the schema information with the connect command. And once broker receive the schema information, it would check if the schema is registered or not. If it's already registered, then it would do the compatibility check. And if it pass the check, then it will register. If the schema already registered before, it will just return the version. So it's kind of all the complexity, all the logic are handled by the broker itself. And similarly, schema consumer also have the same way. And Pulsar not only just store the schema information, but also managing all the schema evolvement. Like you can evolve one schema to next version, and Pulsar keep tracking all the versions and managing all the compatibility check. Then we support like from backward, forward, full to like all the transitive compatibility check. And on the consumer side is when we publish a message to Pulsar, Pulsar would tag the message associated with schema version, which is stored as part of the metadata of each message. And on the consumer side, when you receive a message, you deserialize the metadata from the message. And it will check, it will get the schema version of the associated with this message. and it would try to fetch the corresponding schema information from broker. And it will use the right schema to deserialize the data back into the struct. So in that way, Pulsar keep all the schema information. And when we integrate with Flink, we just leverage the existing schema information and map the schema information into a Flink type. And that's how we did the integration between Pulsar and Flink, is we map individual messages with schema into each row in Flink. So there's kind of two categories of topics within Pulsar. Is sometimes people don't use schema directly. So then, or sometimes people just use a primitive schema, like they use topic to store a string, integer, a long number. So in this way, all this topic would just convert the message payload as a field in the Flink row. Oh, the field is called value. And if the topic is associated with struct schema, like Afro, JSON, and we know the individual fields within this struct, so then we extract the individual fields from schema information and map individual fields to the Flink type. And additionally, there are a bunch of the metadata information associated with each message, like the message key, a topic, a message ID, publish time, event time. Those will be converted into metadata fields in the Flink row. So just give you two quick examples is for primitive schema, like for example, your message is using a double number as the schema. So the Pulsar message would be converted into a Flink row with a field called value. And key, topic, message ID, publish time, event time will just be the metadata field. And the left side example is the Avro schema. So it's a struct. And the struct is a full bar. And it's a nested struct. So all the fields would be flattened into Flink row. So with that being said, is you can get I for as a field for represent the I variable within full. And all the fields in bar would be flattened as bar.b and bar.s. So in that way, you can access all the fields within that struct, even the struct is a nested struct. So, and then we map individual types back into the Flink type system. So once you have this information, then we build all the source, all the sink, and also the catalog based on the schema information. So the new source would look like this. You just need to specify the properties, like how you connect to the Pulsar cluster. You don't need to specify any additional schema information. You don't need to really dealing with the serialization and deserialization. And similarly, you can register a topic, a streaming table in the Flink register table source API. And I think similarly as Think, you don't really need to write any serialization and deserialization in the constructor. And you can also register as table Think, I think. And then you can run any SQL queries insert a result back to the Pulsar. And put all this together is you can register Pulsar as a catalog of Flink. So once you register Pulsar as a catalog in Flink, you don't really need to it simplifies a lot of how you want to process data or query data within Pulsar. And you can use program. You can write program to query the data, or you can use the Flink SQL client to query the data. So the goal, what we are trying to do in our integration is to simplify people for using Pulsar in Flink to building their data processing stack. People probably already know this, like for years, is the most famous Lambda architecture. You have a speeding layer that is consuming data using Flink or any other streaming computing engine to process data from MQ. And you have data like storing in Hadoop and using Hive on any batch processing engines to processing data in the Hadoop system. And with Flink became like a unified data processing engine. It tried to take over both streaming computing and the batch processing. And we are thinking like how we can better serve for the Pulsar users can use Flink to process the data. So what the integration that we are taking here is try to use Flink in Pulsar to build a unified data stack. Flink can be the unified computing engine, and Pulsar can provide unified data storage for both latest data and historic data. And another core of the core strengths that Flink provides is all the state management. And Pulsar itself is not just a message pipe. It's more about a storage. So it can offer a good opportunity for serving the state management for Flink. So together, it can provide a much simpler architecture for the users of Pulsar and maybe for the users of Flink. But we still have a lot of work to do in the Flink in Pulsar integration. Especially, recently we are trying to contribute back our Pulsar connectors to Flink community, but there's a pending work waiting for the new source API to fully leverage the unified like batch in streaming processing. And the other items is more coming from the Pulsar perspective is we are introducing a new type of subscription called key share subscription. It provides some of the advantage combining both streaming and messaging queuing into one subscription mode. We want to use that to leverage the integration between Pulsar and Flink. And the last thing is right now all the source and Sink connector provided in Pulsar. The source is exactly once. The Sink is not exactly once. It's at least once, because on failure you might be publish multiple events into the Sink. And we are working on Pulsar transaction in Pulsar 2.5 release. And we hope with Pulsar transaction we can create an end-to-end exactly once between like multiple Flink jobs. And the other two direction is more coming from the integration, how we want to use Bookkeeper as a state backend for Flink. And also, since we are talking more about like batch processing on Pulsar using Flink, we want to introducing more like traditional like streaming data warehouse features into Pulsar. Like we already have schema, we have tier storage. Right now, we don't leverage schema when we're tiering data from the warm data storage to tier storage. If we can leverage the schema information, we can produce more compact structure stored in tier storage, like using Parquet, ORC, or common data. So that is kind of the direction what we have been working on, try to push the integration between Flink and Pulsar forward. And I'll probably just skip this. So try to conclude my talk here is Pulsar is a cloud-native streaming data storage, and it provides two API of like accessing data, pops up in a streaming way, segment in more batching way. And with leveraging all the schema information stored in Pulsar, you can convert Pulsar streams into a structured event streams. Then you can integrate with Flink type system to query process data more easily. And we hope that Pulsar can become the unified data storage for Flink, and together we can build a great like unified data processing stack. And some of the community information is about website. We have a Twitter account. Also, most of the discussion happening in Slack. It's different from Flink community. Most of the discussion happening in email thread. Somehow, Slack is more popular in the Pulsar community. And the last, since we are speaking in Europe, just try to advertise another community event in Europe. We have a first Pulsar meetup coming up in Europe the day after tomorrow on Friday. It's organized by OVH Cloud at Paris. I think it used to be the Hadoop user group. It's a dedicated session for Pulsar. If you're interested in this session and you happen in Paris, join us. And thank you.
I've got a number of questions, but we can also take it offline.
Okay.
Did I get it right that when you use schema, it's based on the Avro way of doing it?
So we have different types. We have Avro, JSON, ProPath, but all the schema definition we are converting the definition back into the schema. Avro standard.
Okay.
Yeah.
Good.
You mentioned there is a disconnection about the schema in the tiered storage.
Yeah.
So I wonder if my messages start going to the tiered storage, can I not consume them with this structured format anymore?
No, you can still consume it with the schema information, but it's just like we didn't store the data in a more compact way. Like in the warm storage, like in Bookkeeper, we store like each master as in, like, for example, in Avro format. But when we offload to like a tier storage, we just like copy the data to the tier storage. So that all the schema information is still there, but the data is not compact. But when we're talking about the batch processing or like historical data storage, people want to save the cost of storage. You want to use more compact format like Parquet. In that way, we have the schema information in the topic. So when we do offloading, we can convert the master from Avro format to a Parquet format, and in that way, it will save a lot of cost. Yeah.
And I can reprocess all of my messages, like replay them starting from the tier, Bookkeeper, and
okay. You can replay it like from wherever you like to do. Yeah.
I have one question. So starting approximately the last Flink Forward in San Francisco, we started talking about the unified batch and streaming API. Do you see that there is a potential for Pulsar to sort of being a source of the decision of what is, of where the batch data ends and where the recent data begins? So basically, do you see that Pulsar Source could guide Flink as to where the data has to be executed in the batch mode and then maybe fail over to streaming? Something where you really write one program and you say, yes, I want to bootstrap the data with a batch API, but the decision of where this boundary lies is somehow maintained by the user on the Pulsar side. Yeah,
so I think there's definitely a great chance here is from Pulsar perspective, it's fundamentally it's a stream, but we know exactly the boundary between segments, and the segments, the boundary of a segment can be an indicator where the data is storing in either in tier storage or in Bookkeeper, and the latest segment is more about the data cache in Broker. So in that way, you can really indicate like the Flink. Where maybe at this point, before that, you can use a batch processing to process the data more efficiently, and after that, because data is already cached on Broker, you can just fetch data from Broker. That is probably the most efficient way. So I do think there's an opportunity, but I'm not sure how exactly we can integrate with each other. I hope the new Source API could be a good starting point. And because it is at that point, people don't really need to distinguish between like it's a source or it's a batch or it's a streaming. But underneath, I think Pulsar can do more work to differentiate the data you try to access is from like tier storage or from broker, and give back the signal to Flink, and then Flink can schedule the task in the best way.
Yeah, I think it would be kind of a very nice showcase of the capabilities within the story.
Right. Yeah.
Do you think it is possible to completely avoid to use traditional data warehouses?
I think that is kind of a great question. I mean, to be like real, like a traditional data warehouse, I think you still need a lot of work to do. I wouldn't say like to replace it immediately. It's more coming from, I would say, from the new use case that combine both historical data and new data. Just give you an example that one of the users we have been working on with is China Telecom. So they use the Pulsar for like simplify their data processing architecture for real-time risk control. In that way, it needs both historical data and latest data. The historical data you want to build is you use the historical data to build the risk control model, and you use the latest data to training the model. And so we do see the combination of the such use case. Pulsar can benefit a lot. But if you're just talking about replacing a traditional data warehouse, it's probably still quite a lot of work to do so. Yeah. So I wouldn't starting from like traditional data warehouse workload. It's more coming from the new use case, the combination of both streaming and historical data. That could be a great chance. And after that, then if you can address both real-time and historical data in one unified data stack, then we can push more of the use case to traditional data warehousing use case. I wouldn't say that right now. Yeah. Okay. Thank you. Thank you.